How are you, my friends? This is lecture number 31 of the pre-calculus course, Gaussian Elimination Method. For other lecture, please, you can visit the playlist down here. Now, let's see the objectives in this lecture. What is a matrix? We will define it. We will define also the augmented matrix, which is something very important. Elementary row operations, there are 3 there. And then we will solve linear systems using matrices. In this lecture, we will look at Gaussian elimination method. This is method number 4. Now, what is a matrix? Matrix is a rectangular array of real numbers. Real numbers, you can put them in any order like this, rows and columns, like we have matrix A. This is 2 rows here, 2 columns. So we say A is 2 by 2. We can have a matrix B, 3 rows, 1 column. We say 3 by 1. And then C, we can say 5 by 3. The first number always is the number of rows, and the second number is the number of columns. Each number, we call it entry. That is the definition of a matrix. Now, we can represent a matrix by so many elements in a certain location. We have A11, that means the element or the entry, A11 in the first row, first column, A12, first row, second column. See, the first number represents the row and the second number represents the column. So we can have A23, this is the element in the location, second row, third column, etc. So when we say dimension means the rows and the columns, we say M by N. Let's define here the augmented matrix and the coefficient matrix at the same time. Suppose we have a system like this, 3 by 3, 3 equations in 3 variables X, Y, and Z. You have to differentiate between augmented matrix. In the augmented matrix, we take all the coefficients of the variables, 1 minus 1, 6 here, minus 1, 7, 0, 5 minus 3, 2. And then we put a bar. Some people, they don't put a bar here. And then we put all the constant on the other side, minus 11, 0, 31. If you do like this, this is the starting point of methods 4 and 5. Method 4 is lecture 31. Method 5 is lecture 32. So we call this augmented, something large here. Now, the coefficient matrix, we take the coefficients of the X and the Y's and the Z without the constant. So we have like this 3 by 3. This is method number 6 after we finish method 4 and 5. So we call this coefficient matrix. This one is called augmented matrix. Now we have 3 elementary row operations. We can use them in the method of Gaussian elimination method. Interchange any 2 rows. If we have augmented like this, and then we can change any 2 rows, like row 1, row 3, row 2, row 3, etc. So here we have row I and row J can be interchanged. So we have here 1 minus 3, 2, 0. You see that one here? In row 3, we can put it here in row 1 for some reason. And then 2 minus 2, 1, 3, we can put it here in row 3. And we can do that anytime we like, because remember here in the Gaussian method, each row here is an equation. So you can replace, you can interchange, no problem. Now let's multiply a row by a non-zero constant. So we can multiply K times row sub I here. So we have 1 minus 2, 7, 0, 10 minus 20. Let's multiply row 2 here by a number, 1 over 10. You can multiply by 5, you can multiply by minus 6, by half, by minus 2 over 3. So you can multiply any row by non-zero constant. So here we have 1 minus 2, 7. We leave row 1 here. You see that? 0, 10, minus 20. Suppose I need to make this 10, 1. So I can divide. Divide means divide by 10 or multiply by 1 over 10, which is the same here. So it will give you 0, 1, minus 2. We will see that also in the method. And the operation number 3 will be add a multiple. Be careful here. Add a multiple of a row to another row. Now look here, please. 1 minus 2, 7. This is row 1. 3, 4, 1. This is row 2. Add a multiple of a row. So I will take row 1 here. I will multiply it by a number. Let's say minus 3 to make this one 0 here. I multiply minus 3 by the whole row. So minus 3 times the 1 is minus 3. You add it to another row. That becomes 0 here. Minus 3 times minus 2 is 6. You add to 4, you put 10 here. You have to change all the row. And then minus 3 times 7 minus 21. Add to 1, you get minus 20. So remember this one here. Add a multiple of a row to another row. This is the method number 4, Gaussian Elimination Method with back substitution. So in this method, we use also substitution. Now look at the steps are 3 steps. First, we write the augmented matrix. We have defined what is augmented matrix. And then we have to use row operations. Here it says use row operations to change the augmented matrix into row echelon form. Row echelon form means we make ones in the main diagonal. We will see that now. And zeros under the main diagonal. We have to change these numbers. I will show you many examples now. When we finish, we use back substitution to find the final solution. Now, before we start the example, just one more slide here to have to remember. If we have a 2 by 2 or 3 by 3 or 4 by 4 or 5 by 5, we have the same sequence we go to change the ones and zeros. In 2 by 2, you have to make here 1. See, that's the first step. Then you make 0 under that. This is second step. Then you make 1 there. This is the third step. So you have to remember this aim. In Gaussian elimination method with back substitution, you have to remember this aim. 1, 0, 1, so easy. And you have to start here, go there, and then go there. Now you do the same here, I said, and so on. You go the same for 3 by 3, 4 by 4, 5 by 5, 6 by 6, until n by n. Let's see only 3 by 3 what will happen. The first number here should be 1. See, like that one here, step 1. And then under that will be 0. This is step 2. If we have 3 by 3, then we continue. You see, continue in the first column. So if you have 4 by 4, 5 by 5, 6 by 6, 10 by 10, you start with 1, and then you change all the zeros under that 1. Then you move here 1, 2, 3, because we have 3 by 3. So this is 1, 2, 3. Step number 4, we make this one 1 here. And then we continue under that to make 0. And then we move there, we make step number 6. You see, this is 1, 1, 1. That's the main diagonal. Main diagonal. Here we have also 1, 1. Main diagonal. Under the main diagonal is zeros here. Under the main diagonal is zeros. Now we will see the other numbers, A, B, D, C, E, F. We see that in the examples. In example 1, I will show you 3 different questions in one example. Let's use Gaussian elimination method to solve A, B, and C. I will show you directly the first one, then you can try the others if you like. This is the system here, 3x plus 4y is equal to 1, x minus 2y is equal to 7. We are using Gaussian elimination method. So the first thing we have to do, write the augmented, which is the matrix in big size. So this is 3, 1, 4 minus 2, 1, 7. Remember the aim. This number should be 1. Under that, 0. Here should be 1. Now you can divide, I said here, you can divide row 1 by 3 to change 3 into 1. You can divide that. Divide by 3, 1. Divide by 3, 4 over 3. Divide by 3, 1 over 3. But what will happen? You will face some fractions which you don't like. So let's think of another idea. I see here 1 minus 2, 7. You see that here, 1 minus 2, 7? That's row 2. I can interchange with row 1. So now this number here, the aim is there. The first number is 1. So what can I do directly? Interchange the two rows. 3, 4, 1, which is row 1, becomes here row 2. 3, 4, 1, exactly. 1 minus 2, 7, the whole row. 1 minus 2, 7. See, now this number is 1 here. You see, that's aim number 1 in Gaussian elimination method. Now I have to go to change this number 3 to 0. What will happen? The opposite of 3 is minus 3. So this one is ready 1. It's always 1. So I multiply row 1 by minus 3. See, I have to multiply the whole row to change one number. So multiply by minus 3, you add there, you get 0. Multiply by minus 3, you get 6, and 4 you add, you get 10. Multiply with minus 3, 7, that's minus 21, plus 1 is minus 20. See, now I have changed 1 and 0. Now this number should be 1, because the main diagonal should be 1s. So this is 10. What can we do? Divide by 10, or multiply by 1 over 10, remember. So that will be 0, 1, minus 2. Now I stop here and start finding the variables. Just look at the second row here. 0, 1, minus 2, what is that? Just translate it, make it an equation. 0x plus 1y equals minus 2. When you simplify all this, you get y equals minus 2. So I found half the solution. Now what is next? To find x. That's why we call this back. You see, back substitution. Back means we go back like this. We go back to find the x. So I take the first equation, which is ready, x minus 2y equals 7. Remember this first equation. So I put y there minus 2. Okay. So take this in the other side, becomes 2y, put minus 2. So that's minus 4 plus 7. This is 3. So x will be 3 and y is minus 2. That's the solution. Now I can give you a few seconds, please, if you like, to start and try B. Also try and start C. Each one has a different idea. Example, 1A, 1B, and 1C. Now, if we look at the solution of 1B, we see that we have the system 2x plus 6y is equal to minus 3, x plus 3y is equal to 2. Write first the augmented matrix, and then we interchange row 1 and row 2. We have 1, 3, 2, 2, 6, minus 3. We try to make this number here 0. So I multiply row 1, as I mentioned before, by minus 2, and then I will add to row 2. So I will get 0, 0 there, so easy. And then minus 7. Oh, wait. 0, 0 means 0x plus 0y is equal to minus 7. 0 cannot be minus 7. So we stop here. We conclude that the lines are parallel when you graph this line and this straight line. So there is no intersection point. Or we call the system is inconsistent, which means no solution. This is really nice. Let's see 1C. 1C, also we write the augmented matrix, 2 minus 1, 4, minus 6, 3, minus 12. See, here we have minus 6 down, and here we have 2. So we cannot interchange the rows because there is no one there. So what can we do? Just take this 2 and divide by 2 row 1, or multiply by half. So in mathematics, when you say divide by 2, exactly as multiply by half. So this will be 1, this will be minus half, and this will be 2 here. Now I have to make this number 0. So I multiply by 6. Remember, the opposite of minus 6 is 6. And this is already 1. So to make this one 0, I have to add 6 to the minus 6. So I take 1 and multiply by 6. But I have to multiply the whole row. So this one becomes 0 here. 6 times minus half will be minus 3. Add to 3 will be 0 also. 6 times 2 is 12. Add to minus 12 also will be 0. Wow. So 0x plus 0y is equal to 0. 0 equal to 0 is true. And we have solutions, not only one. So we say the system is dependent because these lines are the same line. And we have infinitely many solutions. So this is the same line. So what can I do? Easy. Just be careful here. I have only equation 1 to use because these equations are the same. So I take the easy equation, 2x minus y is equal to 4. Remember, I need x and y. So I can say one way I can do that, let x is equal to t. So I put here x is equal to t. T is any real number. Now I can replace x here by t, and then y will be what? 2t minus 4. So I write here 2t minus 4. That's the general solution, which means whatever t I take real number. Example, if I take t1, so this will be 1 here, 2 minus 4 will be minus 2. So 1 minus 2. If I take t0, 0 minus 4. If I take t5, see here 5, so this 10 minus 4, 6. So that's why when we have 0 is equal to 0, that means the system has infinitely many solutions. So the solution will be general, not one point. This is infinitely many solutions. So you can say x equal t and solve it, or you can say let y equals t and solve it. We will see more and more examples. Now let's look at 3 by 3 now, using Gaussian elimination method. This question, it takes time, but the same way if you understand example 1. So I advise you to understand example 1 before you go deeply in example 2. It's the same process, little longer. We have 3 variables here, x, y, and z. We have 3 equations. We have to rearrange the whole equations. The x will line up, y's will line up, z will line up, and the constant on the other side. And then we start. I think you know the story. This is the linear system. We take the augmented matrix. Be careful about the numbers. 4 minus 2, 1. 1, 1 minus 1. 1 minus 3, 2. Minus 8 minus 4, 3. Now here we have 1 and here we have 4. So directly I can think row 1, row 3, interchange. See the whole row, not the number only. Be careful here. I need here 1, but I cannot change it to 1 unless I take the whole row 3, 1 minus 2, 2, 3 there here, 1 minus 2, 2, 3. That's in row 1. And then whatever in row 1 here, I take it to row 3 down, 4, 1, 1 minus 8. Now, look here, use row 1 because this is already 1 now, so I can use it. Use row 1 to change row 2, row 3. You see the one here? I can make 1, 0, 0 at the same time in one step. How? I look at the number under the 1, minus 2. The opposite will be 2. So I multiply row 1 by 2. See here, 2 row 1 multiply plus row 2. Remember the operations there. This is 4. The opposite will be minus 4 to make it 0. So I multiply row 1, all row 1 by minus 4. We add to row 3. So I will do one slowly here. Let's multiply by 2. You add 0. Multiply by 2, you get minus 2. Add to 1, so there's a minus 1 there. Multiply here by 2. 4 minus 3 is 1 there. See, row 1 does not change row 1. So like we take a copy of row 1, multiply by 2, add to row 2. Row 1 does not change. Okay. Now let's see. Row 1 stays the same. Multiply by minus 4, add, that's 0. Multiply by minus 4, that's 4. Plus the 1 here, you see 5 there. Multiply by minus 4 is minus 8. Plus 1, that's minus 7. Multiply by minus 4, so that's minus 12. Minus 8, minus 20. So we can see from the previous slide, we have changed all the numbers here under the 1. So this is step 1, step 2, step 3. This is step 4. Now I have to make this number here minus 1. In the middle, I have to make it 1. So I multiply directly by minus 1, the whole of row 2. Remember, row 1 does not change now. So this is 0, 1, minus 1, minus 2. Now I have to go from 1 under 1 is 5. Change 5 to 0. How I do that? I use this one, use row 2 to change row 3, remember, because already I have prepared this one 1. The opposite of 5 is minus 5. So I multiply by minus 5. This will be 0 there, minus 5. This will be 5, and minus 7, when you add, you get minus 2. Minus 5 times minus 2 is 10. When you add to minus 20 is minus 10. So this is step 1 again, step 2, step 3, step 4, step 5. This is step 6, the last one here. What do? I need this number minus 2 to be 1. Then divide by minus 2. Divide by minus 2 is 1. Divide by minus 2, 10 by minus 2 is 5. So now I stop in Gaussian elimination. This is 1, 1, 1. All the zeros under the main diagonal. So I take the last row now, 0x plus 0y plus 1z is equal to 5. So directly z will be 5. Now let's use back substitution. So from row 3, I go back to row 2 here to find y. Then I go to row 1 to find x. So use row 2. So look at row 2 here. Y, see y here. This is 0x, I don't write it. Y minus z equals minus 2. So directly I put z there, minus, see the 5 becomes minus 5. On the other side, y will be 3. Now I take row 1. What is row 1? X minus y plus 2z is equal to 3. So I put y there, I put z there. So it will be x minus 3 plus 2 times the 5 is equal to 3. So x will be minus 4. Now let's write the final solution. The first number is the x, minus 4, y will be 3, and 5 is the z. That's the solution of the system. Now this is lecture 31, only about Gaussian elimination method. At the end of lecture 32, after that, which we call it Gauss-Jordan elimination method. Almost the same method, there is a little changes. You can see lecture 32. Then after that, I will put some old exams questions you can practice for both lectures. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is pre-calculus course, lecture 31. I hope I can see you in another video with another topic. Thank you for listening.